Next bit of trigonometry then. So we're going to look at trig identities and trig equations. Okay, so we're going to start off back with our unit circle again. Okay, so I've got my angle anti-clockwise from the horizontal. Okay, and I've got my point P, and because it's the unit circle, I've got a length of 1. Now, hopefully what we can remember is that we can have sine and cos on here as well. Okay, so because sine is opposite over hypotenuse, we'll have my sine angle in here, and we can have cos here. Okay, now we know that the gradient was also known as our tangent. Now, the fact that we call the gradient tan brings out one of our identities. Okay, because we know that the gradient is rise over run. Okay, so rise over run is going to be tan x. When I apply rise over run to here, I get sine x over cos x. So that becomes my first trig identity. So the first one that you need to commit to memory, because we're going to have to use it time and again, is that sine x divided by cos x is equal to tan x. Okay, so that's the first one I need you to make note of, I need you to write down, and I need you to remember. Okay, right, the second one that we can generate from this. We've got right angled triangles again. Something at GCSE that you should have done continually with right angled triangles, not just trigonometry, is Pythagoras. So if I apply Pythagoras to my unit circle triangle, okay, I can say that when I square the two shorter sides and add them together, I get the hypotenuse squared. So what I can say is that sine squared, or sine x squared even, plus cos x squared is going to be equal to 1 squared. Okay. Now if I just tidy this up a little bit, okay, what I will get is sine x squared we actually tend to write as sine squared x. Okay, it means the same thing. And we do the same with cos x squared, so that's going to become cos squared x. And finally, 1 squared is 1. So the second identity that I need you to remember, okay, only 2 this year, we will come across more next year, is sine squared x plus cos squared x will always equal 1. Okay, identities that we need to remember and learn how to use. Okay, so make sure you make note of them. Okay, make sure we understand them. Right, the sort of question we're going to be asked. This is where proof will come into it. Okay, so prove 1 minus tan x sine x cos x is always equal to cos squared. Okay, so a bit like normal proof, what we have to do is we have to prove that the left hand side is equal to the right hand side. So we manipulate one side so that it equals the other. Okay, so I'm going to focus on the left hand side and leave the right hand side where it is. And what I've got to do is think about what I can change. So I've got my 2 identities. What can I spot in here that I can use? Well, I can see I've got a tan here. Well, I know that tan can also be written as sine over cos. Okay, so all I'm going to do is change that bit first. So I'll have 1 lot minus sine theta over cos theta, because that was what tan was. Okay, so that's just that tan part, times by sine theta, times by cos theta. Okay, right. When I multiply these across, okay, what I'm going to end up with is both of these get multiplied up because it's a fraction. So I'll have 1 minus sine squared theta cos theta over cos theta. Now hopefully, algebraic fractions, we can see that I can cancel here. So I can cancel a cos theta with a cos theta. So what I am left with is 1 minus sine squared theta, and I've got to somehow get this to equal cos squared theta. Now, an important thing to remember about this one especially, okay, this identity especially, is from this I can rewrite two more identities, because I can have that 1 minus sine squared x is cos squared x, and I can have 1 minus cos squared x is sine squared x. So those two can be generated from my original identity. So from 1 minus sine squared x, I know now that that is going to be cos squared x. So that will finish me off as cos squared x, or cos squared theta in this case, is always equal to cos squared theta. Okay, so this is all about algebraic manipulation. It's all about using your identities, switching things around, subbing it in, bit of manipulation to make sure the left-hand side will always equal the right-hand side. Okay, right, let's just have a look at another one and we see where we can get to. So, prove that tan theta plus 1 over tan theta is 1 over sine theta cos theta. Again, whenever you've got a tan theta, okay, I would always recommend you swap out your tan theta for your sine theta over cos theta. That's normally the easiest way to go. So, tan theta, I know, is sine theta over cos theta. Okay, and I know that, so that's sine theta over cos theta plus 1 over tan, again, is sine over cos. So I'll have sine theta over cos theta. And that's going to equal 1 over sine theta cos theta. Okay, so just dealing with the left-hand side. 1 over sine theta cos theta, okay, that can be simplified to give me cos theta over sine theta. Okay, just a bit of fractions work where cos theta will come up. So from here, I can then look at adding them together. Okay, so to add together, I've got to have a common denominator. So I'm going to multiply and then cross multiply up. So I'll have sine squared theta plus cos squared theta all over cos theta sine theta. Now what I can see is this is beginning to look more like what I want it to. Okay, so I'm still aiming for my 1 over sine theta cos theta. The only thing I've got different now, okay, is I've got sine squared plus cos squared. However, I know from earlier, from my equation up here, sine squared plus cos squared is equal to 1. So all I need to do, cos theta, theta, sine theta. And we've proved it's the same. Okay, so again, uses both of them. Okay, bit of algebraic manipulation, using the trig identities, and we can work our way through. Okay, nothing massively difficult. You will get more used to these the more we use them. Okay, right, think one last example for you, and then I will get you to do some. Okay, so last example, 5 minus 5 sine squared theta. So no tans in this one, so I'm not going to have to use tan equals sine over cos. However, I've got a sine squared. Okay, now as soon as I've got a sine squared or a cos squared, I know that's the identity I'm going to use. But hopefully what we can notice here as well is that the identity, okay, is all linked to cos squared plus sine squared equals 1. Now at the moment I haven't got a 1. But what I can do is I can take out a factor of 5 here. And as soon as I take out a factor of 5, okay, suddenly I'm back into the sort of position I want. Okay, so notice that factorising is really important. So always watch out for that. Watch out to see if you can factorise. Because if you can factorise things out, you can then use the identities afterwards. 1 minus sine squared I know is cos squared. So this is just going to become 5 lots of cos squared theta. So it's that factorising one we need to be careful of. So if you see a tan x, you need to get it into sine x over cos x. Okay. If you've got cos squareds and sine squareds, that's what you're going to use to help you. Okay, they can be quite tricky, guys. Okay, but you just need a little bit of practice. Right, what I want you to do is have a pause of the video now. Make sure you've written your notes in. Okay, copy down any examples you need to. So pause and rewind where you need to. Can you pause now, have a go at these ones for me, and then we will go through them and I will get you on to the next bit of work. Okay, so pause the video now and have a quick go for me. Okay guys, right, let's have a run through. Now these do actually look a little bit nastier, okay, but they shouldn't be any different to anything else. Okay, so first one, I got a tan x, so let's deal with that first. So I know that tan x is sine x over cos x. Okay, so I'm going to have sine x over cos x times cos x. Okay, now sine x over cos x times cos x, the cos x's are going to cancel out, so all I'm going to have left is sine x. Okay, because these will cross cancel and disappear. So what I'm going to be left with is sine x over the square root of 1 minus cos squared x. Okay. Right, 1 minus cos squared, we know from before, 1 minus cos squared I can write as sine squared. So I'm going to end up with sine x over the square root of sine squared x. Now hopefully we understand the fact that sine squared x is just the same as sine x all squared. So if I'm square rooting sine x squared, I get sine x. So sine x over sine squared x is just going to equal sine x. So this will become sine x over sine, which therefore must be 1, which therefore must be 1, which therefore must be 1, which therefore must be 1. So all my way down, I end up with 1 always equaling 1. Okay, it's spotting these two different identities, guys. So if you've got a tan, you can write it sine over cos. If you've got a 1 minus cos squared or a 1 minus sine squared or a cos squared plus sine squared, you can make those disappear by using your identities. Right, if we have a look at the second one, now I've got to the power of 4s in here. Okay, shouldn't matter too much. Okay, the second one you should have tried then. This one is a little bit harder because your first step could be one that we would miss really easily. This here is actually the difference of two squares. Okay, the top. So what I'm going to do is write the top as the difference in 2 squared instead. So it's going to be cos squared theta plus sine squared theta. Lots of cos squared theta minus sine squared theta. Okay. Now noticing that bit is really, really important. If not, that's going to be quite difficult. Okay. So once we've got to here, we should then hopefully notice that cos squared plus sine squared is 1. Okay, that's a really important one to notice. So that will disappear as a 1 instead. So what I will have is cos squared theta minus sine squared theta over cos squared theta. Then if I separate my fractions, so I can have cos squared theta minus cos squared theta over cos squared theta minus sine squared theta over cos squared theta. Cos squared over cos squared is equal to 1. Sine squared over cos squared will be equal to tan squared theta. And we've shown that the two parts are equal. Okay, that was a little bit tricky, guys, because you've got to spot that at the start, otherwise this gets quite complicated quite quickly. Okay, so best advice is if you start and you get down to a road where it's not quite working for you, go back to the start again and see if we can go a different route to get there, because sometimes we do take the wrong road and that's absolutely fine. Last one you should have tried. Prove that tan squared theta is the same as 1 over cos squared minus 1. So we've got a tan theta again. Okay, so tan squared theta is the same as sine squared theta over cos squared theta. Okay, sine squared, because I've got a cos squared down here, I want to try and keep everything in terms of cos squared. So if I rewrite sine squared as 1 minus cos squared theta over cos squared theta, and we can see we're starting to head in the right direction, I'll separate my fraction again. So 1 over cos squared theta minus cos squared theta over cos squared theta. Finally, cos squared theta over cos squared theta will equal 1. So all I have left is 1 over cos squared theta minus 1. And again, we've proved our two parts are equal. Okay. Just got to get some practice in with this, guys. That's the key. Okay, get used to manipulating and you start spotting the really important parts and where you can carry through to the next. Okay, right. Have a quick look on Show My Homework, see which questions I want you to have a go at. Make sure you get them answered and get them marked, and email me if you are unsure of what is going on. Okay, and I can run through them nice and quickly. Okay.